Hello everyone, welcome to In 5 Minutes. In this video, we are going to start with our next topic and the last topic of Max 2, that is numerical integration. So till now we are given y equal to some function of x and we were supposed to find the value of y at particular value of x. We also used to calculate the derivative and we also used to calculate the integration. But here the function is given, but now the function will not be given. So then also we want to calculate the value of y, we want to calculate the derivative and integration. So how can we calculate that? Of course, there is something which we should assume here. So we will assume some unknown relationship between y and x and we calculate the differences. By using that differences, we can find the value of y for any given value of x. We can also calculate the derivative and we can also calculate the integration. But before calculating all the derivatives and integrations, we have some operators to study. First operator is forward difference operator. This operator is represented by delta. Okay, triangle sign is known as delta. So this operator is nothing but it performs the difference of the forward variables. Okay, so that's why it is called as forward difference operator. So how to use this operator? So let's say x is an independent variable and y is an dependent variable, and we assume y equal to f of x, and this is an unknown function, and we have the values of x going from x0, x1, x2 and so on up to xn, and each value differ by interval h. So that is x1 minus x0 will be equal to x2 minus x1 will be equal to x3 minus x2 and so on, and this whole value will be equal to h. And y0, y1, y2, y3 up to yn be the corresponding value of y's. Then the difference between f of x plus h and f of x is known as forward difference operator f of x. Delta f of x is nothing but f of x plus h minus f of x. That is first forward variable minus the initial variable. Okay. So when we put x equal to x of 0 in this equation, we will get del of f of x0 equal to f of x0 plus h minus f of x0. So what is f of x0? F of x0, when we put f of x0 in this equation, we will get y of 0. So this term is nothing but y of 0. Okay. From here, x1 minus x0 is h. So x1 minus x0 is h. So from here we will get x1 as x0 plus h. So this term is nothing but f of x1. So when we put x1 in this equation, we will get f of x1. So y will be y1. So this term is nothing but y1 minus y0. So del of f of x0. What is f of x0? y0. So del of y0, that is forward difference of y0 is y1 minus y0. Similarly, forward difference of y1 will be y2 minus y1. Similarly, forward difference of y2 will be y3 minus y2 and so on. So we can write this equation in terms of n, that is delta of yn is equal to y of n plus 1. Here it is 0. So 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3. So y of n plus 1 minus y of n. So this is our forward difference operator. We can take multiple times the forward difference operator. So let's consider del of y0. So let's take this part. So delta of y0 is nothing but y1 minus y0. We are again going to take the delta. So delta of delta y0 will be delta of y1 minus y0. This delta and this delta will become delta square y0. And we can take this delta inside. So we have delta of y1 minus delta of y0. Okay. So now if you see here, from here we can generalize our equation as, here we have square, here we have 1, here we have 1. So delta of n times y0 is nothing but delta of n minus 1 y1 minus delta of n minus 1 y0. Okay, so this is also one basic relation between multiple operators you should remember. So this is our forward difference operator, and we will see some basic problem on forward difference operator in our next video. So stay tuned for our future lectures.